Here you see the essential parts of any C program. In this video, we will learn how to sort the array elements, and a method named selection sort will be applied to sort the array elements. But this method will be used with the help of recursion, and to understand this mechanism, let us see here you see an example of an array of size 6. You see 6 elements under the blue background, and these are 12, 19, 8, minus 5, 78 and 21. And I will use recursion. This means that recursion is used when we perform similar type of work. So here we will work for the entire array, this array, and in the next step we will work for this array. You see, this array is smaller than the previous, and after that we will do the work for this array. You see, this is even smaller than the previous one, and after that we do the same work for this array, for this array, and after that we do the work for this array, and at last we do the work for the last array, the last reduced array, that is array of size 1. So if you understand the working of one array, then you can get the working of remaining reduced array. So I show you the work for the longest array, that is this array. And what is the working? Working is to get the smallest integer among these 6. For that we assume S, the first element, to be the smallest element, and at the same time we take its index under T. So obviously T will be 0 and S will be 12. And now we visit the next element, this element, and we compare whether this 19 is smaller than 12 or not, because I am interested in a smaller element, because I have to get the smallest element. So you see that 19 is not smaller than 12, so we go to visit the next element, 8, and you obviously see that 8 is smaller than 12. So the value of S will be updated. Now the value of S will be 8 and index will be, you see, this 8 is under 2, so index will be 2. Now both S and T is updated every time. Now we have visited 8. The visited elements may be colored with, suppose it is yellow. If these are not visible to you, then you may color this with some other color, suppose it is green, or you may take it to be blue. Okay, blue. Now we visit -5, and -5 is smaller than 8, so obviously S will be updated. Now S will be -5, and you see this -5 is under 3, so the index T will also be updated, and this will be 3. Now I have visited -5, so we make it blue. Now I have to visit 78, 78 is not smaller than s, that is minus 5. So there is no need to update s. I make it blue because I have visited 78. Now the last element is 21, and 21 is not smaller than minus 5, so I mark it visited. Now all the elements have been visited. We got s minus 5, that is the smallest element is minus 5, and index of that is 3. Now it is time to swap. We swap the elements because the smallest element should be at the first place. So we have to interchange the positions of these two numbers. I show you. We have to change the positions of these two numbers. 12 and minus 5. For that we swap. You know how to swap. I have already uploaded a video on swap. You can see that. So if you swap, then here will be minus 5, and at the place of minus 5 it will be 12. Now if you observe, then you will notice that the first element, that is minus 5, is at its right place, so I am marking it green. Now as I said that I will use the recursion, so I do the similar process, that to find the smallest. Now I have to find the smallest in this reduced array. This array is one less in size in comparison to previous array, the entire array. And if you do the similar work, then you will find that 8 is the smallest. So this 8, and first element of this reduced array is 19, not minus 5, 19. So this 19 and the smallest element 8 will interchange their position. So here will be 8 and here will be 19. So we have done the work for the first reduced array, this array. So I am going to mark it green. In the same way we work now for this reduced array, and we'll do the same process. In this way you see that the smallest element is at the first place, the second smallest element, that is 8, is at the second place, and if you repeat the same process, then you will get at the end the entire sorted array. This is the mechanism of selection sort. Since we do similar process, so we use recursion to sort the elements. Now let us go for the code. And you know, in a recursion we call a function, the same function calls itself. So there obviously there will be a function call. Before that we take the size, the index number, we take the size, later we take the index, and we show the user a message so that he can enter the size. To scan the size we use a scanf function thereafter. Once you got the size, it is time to declare the array. Now after declaring the array, here we take the index I, we go to get the array elements. Here we will get the array elements. For that we use the for loop, I equals to 0, I less than n, I plus plus to increase the index, and here a scanf function again to get the data for the index, for the elements, sorry, for the elements. Now the sorting parts begin, and we call the function. So first we type a void type, we take a void type function fun, and first will be the address, so int star, and second argument we take an integer. We have declared the function. Now we call the function fun, we pass the address of the first element of the array and its size. Now we define the function, and function is defined below the, you can define anywhere, but it is traditional to define above the main function. But always remember, any program runs from the main function. Int star a, you can take star b as well, I take this time star b, and here int m for the size, and here we begin the definition, and we assume the first element. Here I take j for the index, and we assume here s, we take one more variable for the smallest. We assume s is storing, sorry, here is not a, here is b, the array name is b inside the functions body, and suppose it is storing the value of first element. Okay, and one more variable we take for the index t, and you see the index for the smallest is 0. Now we take a for loop. J, the index j starts from 1 because 0 has been taken by the smallest s. You see b0, s is storing b0, the first element, so we start j here from 1. J will be less than m, not n, because here the size, for the size the variable is m, and thereafter j plus plus to increase the index. Now we compare. For the comparison we use if keyword and observe aj, whether aj is less than s. If it is true, then s will be updated s will take the value of aj, so here will be s equals to aj, and at the same time we store the index under t, that index under t which corresponds to the smallest value. Now the time comes to swap the elements. So here we swap, and for that we take one more variable temp, and here we store the first element in temp. Here is b, and this b0 is given the smallest value because the smallest value should reside at the first place, and that place with index t will store the value under t. Okay, this is for the entire array. I have not written the code for the reduced array. I have shown you earlier the reduced arrays. So now we generalize, and for that we again call the same function, because in recursion we do the similar process, and I have shown earlier that in the mechanism that we do the similar process for the reduced arrays as well. So for that we again call the function fun, but this calling will be under a condition. You know, whenever you use a recursion, there will be a base condition to terminate the recursion thing. So here you know m must be greater than or equal to 2, because m is less than 2, that is m is 1. This means that the array is of size 1, and you know the array of size 1 is already sorted. There is no need to work for that. So I have taken the condition as m is either 2 or greater than 2, and now we call the function fun, and this time we call the function for the reduced array. Now the index number starts, first it starts from 0, for the next time it will start from the index number 1. So the array is b, and here we add 1, and since we do the similar work starting from the index number 1, so size of the reduced reduced array will be 1 less. So size is m here, so it will be m minus 1, and thereafter there will be else condition. Else, in that, this means that if m is not equal to 2 or greater than 2, then we have to print the result. We have to just print the result. And for that we need the size of initial array, and for that we have to add one more argument here in the function int. So in the function call we have to write 3 things. You see already there are 2, a and n, and one more, that is n, and accordingly here will be one more argument int n. n is constant. Accordingly, here will be n, and now in the else part, I go to print the sorted elements, the elements of the sorted array. For that, I use printf function, and here I type the statement: the sorted elements are, the sorted elements are, and here we use the for loop again, and I equals to 0, I less than n, I plus plus. Here we use the printf functions to show the elements, %d of backslash t to get the elements at a type distance, and now here b I, because b is the array name inside the function definition. Now I think our program is okay. Now I show you the entire code. Here is the first half of this code, and this is the second half of this code, and this is the last part of this code. I am going to run it, whether it is working or not. Okay, it is showing some error. I was not declared. It says I. Okay, yes, I has been not declared. I have declared J. So, and I have taken the array name B. You see B, so here will be B, not A. Inside the function definition, I have taken B. You see here B. So here will be B, not A. And accordingly, I have declared J inside the function definition, not I. So here will be J, not I. J, J, J. Now I think it is okay. It says enter the size. I place 7, so I have to insert 7 elements. 56 minus 9, 8, 6, 5, 45, 7, and you see the sorted elements are. So our program is not working well. Something is some error is, some mistakes are there. Let us seek those mistakes. Here I have taken n. I have to add one more argument. For that I take int star. I have to add one more because this b has been this b is being changed after each function call. You know, for the reduced matrix, the first index, if you see the reduced matrix after seeing the largest array, sorry, not matrix, array, after seeing the largest array, then its index will not be 0, it will be 1, and for the next time it will be 2. But if you see the reduced matrix only, then its index will start from 0. So I have to take one more argument inside. So here accordingly I have to take here int star b, and now there are 4 arguments. Here will be the 4 arguments, and here I take a once more. So now we have 4 arguments. These 2 arguments, one and the second one, these 2 arguments changes these 2 arguments change every time. Now here will be a, let us run this program now. Okay, here I have not taken 4 arguments because I have changed the number of arguments. So here accordingly I have to take 4 arguments. Now it is okay. It says enter the size. I take the size 6, so I have to insert 6 integers, 0, minus 8, 7, 9, 6, 4, and you now see the output. This is the output. This is the output, and our output is sorted. You see, these are in ascending order. Let us take in this video, in this program, we have shown, I have shown that there were many errors. So for the confirmation, we take one more example. I show you the entire code once more. This is the first half. This is the upper part of the code. This is the middle part of the code, and this is the lower part of the code. Now I am going to run it again for the next value, for the other size, to check whether it is working for all the sizes or not. Now this time I take the size to be 12. So I have to take 12 numbers, 0, minus 9, 8, 7, 8, 9, 5, 6, 9, 9, 8, 8, 3, 4, 5, 6, 4, 5, 6, 7, 8, 9, 7, 3, 4, 2, 3, and you can check that our program is okay. Here you see the output, and in this output the numbers are in the ascending order. So our array has been sorted, so this program is okay. I am showing you the entire program once more. This is the upper part of this program, of this code. This is the middle part, and this is the lower part.